Let's talk a little bit more about complex numbers. Complex numbers come from quadratic equations. If we have a quadratic equation with real coefficients and it has complex zeros, those complex zeros will come in conjugate pairs, A plus or minus BI. So if we want to solve this equation, our most efficient way. Okay, our most efficient way would be to be the person that wrote the equation and know what the solutions are going to be, but that's beside the point. So a nice efficient way to do this is to just use a machine to ask and find out the solutions are 3 plus or minus 2i. 3 plus or minus 2i. We had a quadratic with real coefficients, and it had complex zeros. The complex zeros all in conjugate pairs, A plus or minus BI. The interesting thing to note here is that we use the quadratic formula program on our calculating machine to find this. The quadratic formula is just completing the square. The quadratic formula is trying to rewrite this this equation in vertex form. So we use the quadratic formula specifically the quadratic formula program. But this is the same thing as completing the square. Completing the square is where the quadratic formula comes from. And completing the square is writing the equation in vertex form. No. You can always write it out by hand. It's just efficient for solving quadratic equations. That's okay. You probably have a sign or parentheses or somewhere missing.
You didn't look it up on
Let's see. I'm recording, so you could just. I'm actually messed with mine a little bit, but this is. Go ahead and pause, and you can program it this way. The important thing is all the parentheses that I have here are necessary. So parentheses, negative b plus square root. That first parentheses after the square root is assigned by the square root button. Then b squared minus 4ac. We close the parentheses to close the square roots. That second closed parentheses closes the numerator. Then we divide by 2a. We need parentheses around the 2a because the calculator will just follow the order of operations. It will divide by 2 and then multiply by a, and that's not what we want to happen. I want 2 to multiply by a, and then I want that to be the parentheses around that. I put in store as P and Q, so I could recall the zeros individually if I wanted to. But what I wanted to test out is if I could just do Q, Q. I wonder if I can do this. Cool. So there's a nice efficient quadratic formula program that will allow you to pull the individual zeros if you need them. So now, if I needed the zeros, I could put alpha p, and it'll give me that one, and alpha q, give me that one. Or if I want to do like alpha p squared minus 6 alpha p plus 13, that would come up with 0. I assigned names to the two zeros, to the two solutions, so I can grab those two solutions if I wanted to work with them a little bit more. And it's still a very small
efficient program. If you look for a quadratic formula program online,
they are very excessive. Every time I find one, it's like, oh, it tells you what kind of the zeros, grabs the discriminant and analyzes it, and says, oh, there's gonna be 2 complex zeros. I'm like, well, dude, just tell me what they are, and I will be able to identify that they are complex zeros.
and really it was just an exercise in programming. And if you just download an exercise in programming and load it onto your calculator, you're not doing the exercise in programming. But that's all beside the point. The important prompt is to get that. Let's see, create new Q L 2. To get prompt, press program and go over to IO for input output, and it's the second one, prompt. Yeah, while you're programming, press program and then go over to the IO for input output and then hit enter for prompts. And then alpha A, comma, alpha B, comma, alpha C. And then hit enter. Program, IO, and it's number 2. That's also, IO is also where you're going to find display. Disk for display. That's to tell your calculator to show you these results. If you don't put it in the display, it'll just calculate the 3 zeros and just sit there. It won't tell you. That's like when you ask your friend, do you know what time it is? And they're like, oh, yes.
Or when you ask the teacher, can I go to the bathroom? And the teacher's like, oh, I don't know, can you?
Incidentally, the boss move for that, none of you will be brave enough to do this, but the boss move for that is to pee your pants right there and then say yes. So if your teacher's like, oh, I don't know, can you? So hang on. Yes. Now, can I go get some towels? Or if you don't want to do that, one level down from that is if the teacher's like, oh, I don't know, can you get up, walk out, go to the bathroom, come back and say yes.
I feel like you're hurting yourself.
Yeah, that is more commitment to the bit than I think anybody would be.
That's so much.
Yeah. But I mean, then, and it'd be one thing if you did it in my classroom because all my classes are in this room. Now, if you did it in this particular class, I'm leaving right after this class, so not really suffering, just the next class is suffering. And if somebody in my 12 o'clock class did it, then they would only, I'm not sure there's an intersection where people in this class are sitting in the same location as people in my other class are sitting. All beside the point. So we've got our quadratic formula. That's the efficient way to use the quadratic formula. It's just, we get the quadratic formula by completing the square, that is switching to the vertex form. So we're looking to do that. We look at x squared minus 6x, and we think about what constant would go here to make a perfect square trinomial. That's going to be x minus 3 squared. So I think, what do I need to complete the square? And so we take a half of the 6 and square it, and that gives us plus 9. So what will make a square is a plus 9. The traditional thing to do is to add 9 and then subtract 9. Because then you add 0. This is the nice traditional move, because it fits the description of add 0 as one of your great math maneuvers. So the first plus 9, it goes with the x term, x squared term, and the x term, and that becomes the x minus 3 squared. Plus 13 minus 9 becomes a plus 4. So here's your 3 in the vertex. There's the 4. sitting above the y, the x-axis, giving you no real zeros. But if we just solve by doing inverse operations in reverse order, then x minus 3 squared is -4. So x minus 3 is plus or minus 2i. And so x is 3 plus or minus 2i. Now, we of course, see this and see more writing and say more writing is bad, but more writing doesn't have to happen. This all can take place in your mind. You see x squared minus 6x, you know the real part is going to be 3. You know where the vertex is. And then you think the 9, take the 9 off of the 13, that leaves a 4, so plus or minus 2i. So this can happen quickly in your mind. But if you're using the quadratic formula, then you are completing the square. So you don't get to be like, oh, I don't complete the square, I use the quadratic formula. Those two are the same thing. Here it is. It's just writing the vertex form. So one of the things that's that I don't really like about the quadratic formula is that we kind of miss out on completing the square. But if we look at the structure, the traditional structure is negative b plus or minus the square root of b squared minus 4ac, and then we say all over 2a. Those are the traditional lyrics to the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's not exactly how we should say this, but that's the way that we can use to, that's the mnemonic we can use to remember this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It's easiest to remember when you write it and when you say it. And when you're saying it, you're trying to learn this as lyrics, you need rhythm. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Put a rhythm on it. It doesn't have to be good rhythm, but it just has to have, it doesn't have to have a good pocket. It just has to have a pocket. It doesn't have to be like stylish or anything like that. Marching band style, not jazz. Because jazz, you're going to want to be behind the beat. It becomes, it sounds better, but it's not going to help you remember. So you want a rhythm to it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Has to have rhythm. Marching band rhythm. Stiff. Not cool marching band rhythm. Uncool marching band rhythm. Beginning marching. And if you can put melody to it, then that helps even more. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Congratulations. Now you'll never fucking forget the thing. No, I've known that for a long time, and I have to infect all of my students with it. Oh my God, that's it. That's okay. You were lucky you didn't have to hear the choir formula in the song.
I'll sing it.
Yeah, it fits the Pop Goes the Weasel. Because if you want to remember the quadratic formula, it needs rhythm, and if you could put melody on top of that, then that's even better for you to remember. It's just like remembering a song that you've heard a million times. All you have to do is hear the song a million times, and then you know the words, if you can tell what the words are in the first place. I don't know, because if you want to do that, you don't actually have to know the lyrics. You just have to have the right sounds. I'm talking about songs where there's like good articulation, and I still can't hear it. I also don't know like names of bands, names of songs, and even more like names of members of bands. Oh, it's like this one guy. Oh, who the hell is that? You know, he's in that this band. Like, oh, what band is that? They do this song. I'm still not with you. Then they sing the song. I go, oh yeah, I've heard that. Yeah, I know what song you're talking about. But anyway,
Arrow.
the arrow is the stow button. So stow is right here above the, next to the one. That's if you want to stow a number as, and then you put a letter after it. So you're like, I'll stow this as,
I don't think.
no, you're stowing it. I'm glad about one thing. I don't know how old your calculator is, but there's a button that's labeled matrix. See, it's like a MATRIX, and this one is like all lowercase. So early iterations, the whole thing was in all caps. There was no uppercase, lowercase. And they abbreviated matrix, and they abbreviated it MATRX. And I don't know why, but this made me irrationally angry because they eliminated the skinniest letter there was. Just find a way to cram the I in there. I mean, look at the I. Look at the capital I. Texas Instruments. I don't know if you're listening. You have a friggin' I in your name. But look at the I that they use. Look at the I. You see, the I is sans serif. That is the skinniest possible letter, and that's the one they eliminate from the abbreviation for matrix. And I call MATRX. Let's do the least possible abbreviation. Get rid of the skinniest letter on there. Just find a way to cram it in. So annoyed. That's why I had to get a different calculator. This one happens to be color and like with rechargeable batteries and stuff like that. But I mean, that's all. That was all secondary. Once I saw that they got rid of that stupid abbreviation, I go, oh no, okay, I can replace my calculator now. I don't know. I don't know, maybe I have a different one, but the button feel here is good. No, I don't like the older button feel. And the Casios with the little rubberized buttons, that's right out. That's just completely unacceptable. The feel is all wrong. Anyway, what are we talking about? Oh, yes. So what we want to notice about the quadratic formula is that it kind of like mashes everything up over the 2A, and I much prefer it split, even though this is like unsimplified because it has the two parts. And this negative b over 2a, by writing the quadratic formula this way, it really calls out the x-coordinate of the vertex as being important to the solutions. So it really like highlights this negative b over 2a as the x-coordinate of the vertex. And this signals that there's symmetry in your solution. There's a middle to your solution. The middle is at negative b over 2a, the x-coordinate of the vertex, and the two solutions are split evenly around the middle. It's really saying the x-coordinate of the vertex in the middle . And the in between the two solutions is where that plus and minus comes in. You have the middle plus some amount and then minus the same amount. So if we have a parabola, by writing the quadratic formula in these two separate pieces with the plus or minus in the middle, we're highlighting the symmetry of the parabola where a vertical line through the vertex is a negative b over 2a, and then here's plus and minus. Utilizing the symmetry. So I kind of prefer negative b over 2a plus or minus square root of b squared minus 4ac. So we can see what the middle part is going to be. We can see that if I have like x squared plus 8x plus 25 equals 0. I know that my x coordinate is going to be x. We're going to have x plus 4 squared. In the middle, there's going to be, the middle is going to be a negative 4. So x is going to have a negative 4 plus or minus something. Once I know that that's going to be, once I know that tells me the reason that I'm taking the 8 and cutting it in half and then squaring it. Half of 8 is squared is 4. So to complete the square part would mean a 16. I didn't leave space. So half of 8 is 4. 4 squared is 16. That's what I need to complete the square. And then if I subtract the 16 from the 25, I'll just write it out the traditional way. +25 minus 16 is going to give us the plus 9. Now that I've got this plus 9, I know I'm going to have the square root. This is going to go over here and then get square rooted. So plus or minus 3i. And we'll check if it went right. So if we break apart our quadratic formula that helps us complete the square, by completing the square, we can bring in our knowledge of the symmetry of the parabola. And that vertical line through the vertex is where the middle is going to be. It's a little more complicated if this number is messy. Like or it's going to make things messy, but really we're still only cutting in half. So if this is like plus 7x plus 25 equals 0, then in the middle is going to be an x plus 7/2 squared. But that's still going to tell us where the middle is. If we want to figure out what the square root part is, I'm going to take 25 minus 49 over 4. But if we think about the structure in the vertex form and how these two are related through that square trinomial, take the middle term, cut it in half, that'll tell us where the middle is, and then just subtract the square from the constant. A quadratic will always have the shape of a parabola. All right, so next week we will talk about how trigonometry shows up in the complex numbers. That's going to require some more graphing and stuff. So that's the fun part. But here's your background on complex numbers. They've mainly come up in algebra when we're solving quadratic equations, because there's a square root of b squared minus 4ac that might have the square root of a negative number. So that's why complex numbers become necessary. So that's it for today. That's it for this week. We'll talk about more complex numbers and trigonometry next week on Tuesday. Everybody have a good weekend, and thanks for playing.